Hi, I'm DJ Colella, and this is my informative speech. Let me pan around to show you my audience. Of course, there are only two because the third member of my audience got sick at last minute and I couldn't replace them. I apologize for that. Imagine a star that is 8 times the size of our sun, which is already 30 times the size of our Earth, so you can imagine how large it actually is. Now this star goes about its life combining hydrogen to make helium. Once it's out of hydrogen, it combines helium to make carbon. Carbon into oxygen, then neon, then silicon. Then after silicon comes iron. Now, once it starts making iron, it takes more energy to make iron than can be produced afterwards. So because of that, the star starts collapsing on itself. And once it does that, it implodes and makes a supernova, which is an incredibly large explosion. So large, I don't believe anything on Earth combined could comprehend what a supernova would entail. The explosion is so large. So large, in fact, that it causes a major rift in time and space. Now, if this rift in time and space is so large, it can make a black hole. What is a black hole, I hear you ask? According to a well-known source, a black hole is a region of space where large quantities of matter have been compressed by gravitational forces into infinitesimally small volume. What does that mean? Well, let me show you. If I can get 2 volunteers. Thank you, 2 volunteers. Now, this sheet represents time-space. Now, time-space is actually 4-dimensional. We travel in a 3-dimensional world, up, down, left, right, cat-a-corner, any way you can imagine. But the 4th dimension includes time. Now, let's let this canister represent a planet. If a planet is plopped into space-time, you see it leaves a dent around space-time. This is what gravity is. This is how gravity works. If an object smaller than this planet were to go past, it would be caught in this dent, and instead of going straight forward as 4-dimensional thinking would comprehend, it would go around the dent and eventually either change paths or even orbit if it has enough speed. Now, our sun, which has a much larger mass, will make a much larger dent. As you can see, this is how our planet goes around the sun because of this rift in time and space. Black holes are, even though they are a singular point, they have so much mass in that singular point that it can cause time-space to dent so large that the walls of time-space become parallel. Now, around this parallelism is called the event horizon. Once any object goes past this event horizon, it immediately becomes sucked into this black hole. Now, I said any matter, even light, which travels faster than anything else in the universe, gets trapped into a black hole. Thank you. So, since we can't see the light that escapes the event horizon, how do we know these black holes exist? Well, scientists who observe the celestial skies have seen various different things that would, only be explained by a black hole. For instance, around a black hole, light that goes just above the event horizon will be bended, like as if you saw a lens from far away. You can see how light jumps upside down. Black hole does the same thing. And also, if an object goes near a black hole, obviously we can't see the object going near the black hole. However, we can see the object being obliterated and torn apart as it goes towards this black hole. The best evidence for a black hole, though, is towards centers of the universes where X-ray gases will be spewed out because of how much energy is going into this black hole. Once enough energy goes into a black hole, it heats up so much past visible light, going beyond UV light and going into X-ray light and being spewed back out. And this is a very big characteristic of black holes. This is how we know they are around. Now, we know so far beyond this presentation that black holes suck things up. But what else do they do? Let me explain. There are such things as supermassive black holes. Now, these are different than what I explained before, which were stellar black holes. Supermassive black holes are what happen when a giant group of stars all implode at the same time, creating a giant massive black hole. These black holes are believed to be in the center of most galaxies, including our own. And fun things happen when you're near a black hole. For instance, if you are indestructible, and nothing in the universe is, but let's say you were indestructible, if you were to go near a black hole, you would never really seem to reach the event horizon, because all the light you see is bended in such a way that you never see the event horizon until it's too late and you'd be smack dab into the center. Of course, most things in the universe aren't indestructible. So what really happens is, let's say a human were to go near a black hole. At first it would feel really good because you get a good stretch, but afterwards, since your feet would be closer than your head, your feet would be pulled farther than your head and you'd be torn in half. Now these two halves would be split into fourths, then eighths, then 16ths, 32nd, 64th, 128th, so on and so forth, down to the molecular level, where even molecules would be separated into atoms and neutrons and electrons, and even neutrons and electrons would be split so much so that there would be no mass left. This is what happens in the center of a black hole. But as long as you never decide to go near a black hole, you'll be fine. Of course, there's a lot we don't know about black holes. We don't know how they work. It's impossible to send something into a black hole and have it send something out, since not even light can escape a black hole. So